In this video, we will talk about Top 10 Basic Algebra Concepts. 1. Variables and constants. In algebra, variables and constants play crucial roles. Variables are symbols, such as x or y, that represent unknown values we need to determine. For example, in the equation x plus 5 equals 12, x is the variable. We don't know the exact value of x right away, but we can find it by solving the equation. Constants, on the other hand, are specific numbers that remain the same throughout the problem. In this equation, the numbers 5 and 12 are constants. They provide fixed values that do not change. Understanding the difference between variables and constants is essential for solving algebraic equations. Variables allow us to work with unknowns and create general formulas that can be applied to various situations. For instance, in the equation x plus 5 equals 12, solving for x involves using algebraic methods to isolate the variable and find its value. Constants help us by giving precise numerical values that we use to solve these equations. They provide the specific data we need to complete our calculations. Knowing how to distinguish between variables and constants helps in forming equations and understanding their structure. It allows us to manipulate equations and solve for unknown values effectively. This foundational concept is key to mastering algebra and applying it to solve real-world problems. 2. Algebraic expressions. Algebraic expressions are combinations of variables, constants, and operations like addition, subtraction, and multiplication. For example, in the expression 3x plus 2, 3x is a term involving a variable, and 2 is a constant term. The variable x represents an unknown value, and the coefficient 3 indicates how many times x is used. When working with algebraic expressions, simplifying them helps make equations easier to solve. For instance, in the expression 2x plus 3x, 4, you combine like terms to simplify it. Here, 2x and 3x are like terms because they both involve the variable x. Adding these terms together gives 5x, so the simplified expression is 5x, 4. Simplifying algebraic expressions involves combining like terms, which means grouping together terms that have the same variable. This makes expressions easier to work with and understand. For example, if you have an expression like 4a plus 2 bits, 3a plus b, you combine 4 and minus 3 to get a, and 2 bits, and b to get 3 bits, resulting in a plus 3 bits. Expressions are essential in algebra because they form the basis of equations and inequalities. Understanding how to simplify expressions helps in solving problems and analyzing relationships between different quantities. It allows you to manipulate and solve equations more effectively, which is crucial for tackling various mathematical and real-world problems. 3. Equations and inequalities. Equations and inequalities are fundamental concepts in algebra that help solve different types of problems. Equations are mathematical statements that show two expressions are equal. For example, in the equation 2x plus 3 equals 7, the goal is to find the value of x that makes both sides of the equation equal. To solve this, you isolate x by performing operations that simplify the equation. In this case, subtract 3 from both sides to get 2x equals 4, then divide both sides by 2 to find x equals 2. This means when x is 2, both sides of the equation are equal. Inequalities are similar to equations, but instead of showing that two expressions are equal, they show that one expression is greater than or less than another. For example, 2x plus 3 greater than 7 means that 2x plus 3 is greater than 7. To solve an inequality, you perform steps similar to solving an equation, but interpret the solution differently. Subtract 3 from both sides to get 2x greater than 4, then divide by 2 to find x greater than 2. This tells you that x can be any number greater than 2, not just a single value. Understanding equations and inequalities is crucial for solving a wide range of problems. Equations help find specific values that satisfy a condition, while inequalities help determine a range of possible values. Both are essential for analyzing and solving problems in various fields, from basic math to complex real-world situations. 4. Functions. A function is a relationship where each input has exactly one output. For example, in the function fax equals 2x plus 1, every value of x gives one unique value for fax. Functions can be represented as equations, tables, or graphs. Graphing fax equals 2x plus 1 shows a straight line, demonstrating how input values are transformed into output values. Functions are crucial for understanding how changes in one quantity affect another. 5. Linear equations. Linear equations involve variables raised to the first power and produce straight-line graphs when plotted. An example is 3x. 4 equals 7. To solve, you isolate x by adding 4 to both sides and then dividing by 3, finding x equals 11/3. Linear equations model relationships with constant rates of change, such as speed or cost per item, and are foundational in algebra for understanding linear relationships between variables. 6. Quadratic equations. Quadratic equations involve variables squared, like x caret 2, 5x plus 6 equals 0. These equations form parabolas when graphed. Solving quadratics often involves factoring the equation into x, 2x, 3 equals 0, giving solutions x equals 2 and x equals 3. They can also be solved using the quadratic formula x equals frac backslash bone, skirt caret 2, 4 acres 2a. Quadratics model scenarios where rates of change are not constant, such as projectile motion. 7. Exponents and powers. Exponents show how many times a base number is multiplied by itself. For instance, 2 caret 3 equals 8 means 2 is multiplied by itself 3 times. Understanding exponent rules, like a caret m dot a caret n equals a caret m plus n, simplifies expressions and calculations. Exponents are used in various areas, including scientific notation and growth models, helping in expressing large numbers and understanding exponential growth. 8. Factoring. Factoring involves breaking down algebraic expressions into simpler components, such as x caret 2 to 9 factored into x, 3x plus 3. This process is used to simplify equations and solve for variables. Factoring helps in finding the roots of equations, making it easier to solve polynomial equations. It's an essential skill for working with polynomials and solving complex algebraic problems. 9. Systems of equations. Systems of equations consist of multiple equations that share common variables. For example, consider the system x plus y equals 10, x, I equals 2. In this system, x and I are the variables we need to find. The goal is to determine the values of Zandy that satisfy both equations at the same time. To solve these systems, we use methods like substitution or elimination. In substitution, you solve one equation for one variable, and then substitute that value into the other equation. In elimination, you add or subtract equations to eliminate one of the variables, making it easier to solve for the remaining variable. Systems of equations are useful in various real-world situations where multiple conditions must be met simultaneously. For instance, they can model problems involving budgets, mixtures, or any scenario where several criteria must be satisfied at the same time. By finding the values that work for all equations, you can solve complex problems that involve more than one constraint or condition. 10. Polynomials. Polynomials are algebraic expressions made up of multiple terms, like 4x caret 3, 2x caret 2 plus x, 7. Each term includes a variable raised to a power, combined with coefficients, numbers, and constants. For instance, in 4x caret 3, the term 4x caret 3 has a coefficient of 4 and a variable x raised to the power of 3. Operations with polynomials include addition, subtraction, and multiplication. To add or subtract polynomials, you combine like terms, which are terms with the same variable raised to the same power. For example, in 4x caret 3, 2x caret 2 plus x, 7, you can add or subtract x terms with other x terms and constants with other constants. When multiplying polynomials, you use the distributive property, multiplying each term in one polynomial by each term in the other, and then combining like terms. Polynomials are crucial in algebra because they help model a wide range of real-world situations and relationships. They are used to solve equations, represent functions, and graph various types of curves. Understanding polynomials allows you to handle complex algebraic problems, analyze relationships between variables, and find solutions to equations involving multiple terms. What do you think of our video? Let me know in the comment section below. If you enjoyed this video, make sure to hit that like button. Also, subscribe to our channel before you go. Thank you for watching.